Imagine walking through a wall. It seems impossible, right? Yes, I was talking about walking through a wall. So wall is there. How can you move through the wall? That means what is the requirement? The requirement is you need to tunnel through the wall. But since the wall is present, you cannot do that thing. So this is true according to the laws of classical physics, according to the rules of classical physics. But you know that quantum world is somewhat different. In the quantum world, something extraordinary happens. Laws of quantum physics and laws of classical physics are different. What impossible in the realm of classical physics becomes possible in the realm of quantum physics. So there is a difference, and that difference is known to you. So here we are talking about the subject field, means topic. Here we are talking about the topic quantum tunneling. Here what happens, reality of the universe is rewritten. Here also there is a barrier, and the barrier is having an energy. And there is a particle in the quantum world or the quantum system. Yes, there is a particle. You know, quantum physics deals with the tiniest particles. So just suppose there is a particle in your in a quantum system, and there is a barrier in front of that particle, and that particle tries to move through that barrier. Question is whether this is possible or not. According to quantum physics, this is possible, and there are experimental evidences supporting this. Say we are talking about electron. Okay, say we are talking about electron, so there is a barrier. That means here we are talking about that electron is having some energy, that barrier is also having some energy. The required energy is not possessed by the electron to overcome that barrier. If you calculate using the rules of classical physics, the energy of the electron is less than the energy of the barrier, means energy which is required to overcome that barrier, that is not possessed by the electron. Still, in the quantum realm, in the quantum physics, in the quantum system, this is possible. The particle can move through the barrier, and this is known as quantum tunneling. And in reality this happens, and scientists are already using this as a technology in different fields such as semiconductors, tunnel diodes, scanning tunneling microscopes, again in stars, okay, you know, hydrogen nuclei fuse together to form helium. So that becomes possible due to these quantum tunneling effects. Because you know that in case of stars, Coulomb laws of attraction is there, and due to that repulsion should be present over there. But hydrogen nuclei stay together to form and they fuse to form helium. Again in case of alpha decay. Okay, so many examples are there where you can see this effect, and scientists are successfully using this effect in different devices. Okay, so how this is possible? That is the question. In the quantum realm, this is possible, and practical evidences are also there. Already technologies are there where this effect is being used by the scientists. So you know that in the classical sense, electron is nothing but a dot. It's just a particle. But according to quantum physics, you know that an electron can be considered as a particle as well as a wave. That means it can be represented by a wave function. And you know that amplitude of the wave function never becomes zero. exponentially the wave function, the amplitude of the wave function may decay but never becomes zero. That means there is a probability that the electron wave, here the particle wave is what? Electron wave. We are taking the example of electron. So here the electron wave remains present both in front of the barrier and behind the barrier, even inside the barrier. Though the amplitude of the wave function becomes becomes less than the particle's energy. Okay, so that is one thing. Next is superposition. According to the principle of quantum superposition, you know that the particle is available everywhere. It is a superposition of states of the particle. That means the particle or the electron here in this case can be present at many places simultaneously. So there is a chance that the particle remains present over the barrier, or means behind the barrier. So that way tunneling becomes possible. Then if you talk about that Heisenberg's uncertainty principle, so according to that, delta x into delta p, where delta x is the position, delta p is the momentum. So this product delta x into delta p is greater than or equal to h line by 2, where h line is nothing but Planck's constant. So to maintain this principle, what is that principle actually? Either of the two, position or momentum, cannot be precisely determined simultaneously. That is the principle. And this is what? This is an intrinsic property of this quantum particle or the quantum system. That means it is possible to borrow energy and appear in forbidden regions. Here forbidden regions means inside the barrier or behind the barrier. Okay, so restrictions in the classical physics and restrictions in the quantum physics, in the realm of quantum physics and in the realm of classical physics, restrictions are not same. Okay, it seems to be impossible for us because always our brain thinks according to the laws of classical physics. Our everyday life experience is what? That is actually according to the laws of classical physics. That way our brain has become ready to analyze the things. Our brain uses logic according to the laws of classical physics because that is our experience, not according to the classical physics. That's why according to us, means according to our brain, according to the human brain, many phenomena are there in the realm of quantum physics which appears to be impossible. This is just for our brain. In reality, all these things are happening. And scientists are successfully using this thing. Okay. So many reasons are there for which this becomes possible. Though the particle has less energy, means if you calculate according to the laws of classical physics, the particle has less energy as compared to the barrier. Still it is possible for the particle to overcome that barrier. That means tunneling through the barrier. Okay, so this is known as quantum tunneling. And this is being used successfully in different fields of technology. Anyway, so this was all about today's topic, and this is the end of this video. Thank you for watching this video.